Alright, so I think most of you stopped at slide 10 or after that, so feel free to skip ahead into where you were at for your notes. This slide right here is using the concavity test on the function f of x equals x squared. So we need to find our second derivative. So we take our first derivative first, which is 2x. Then you take your second derivative, which is 2. So the interval part of this example is really not important because my second derivative is 2, which is always positive for every interval. So since the second derivative is greater than 0, then the graph is concave up wherever this graph exists. So the second derivative test, if the second derivative is positive, then your function is concave up. This is just an example of how we can see concavity, where concave up and concave down, and that point right there where it switches is called our point of inflection. It is a point, so it usually involves an x and a y. So as you're writing down an answer of a point of inflection, don't just put an x value, put an x and a y if possible. So how do we find that point of inflection? Here is a function right here. We find its second derivative. In order to find the second derivative, we find the first derivative first. So first derivative would be 2e to the negative x squared times the derivative of negative x squared, so negative 2x. I'd probably rewrite that like negative 4xe to the negative x squared. Then I go through and find the derivative of that using the product rule. So second derivative is the first times the derivative of the second. So negative e to the negative x squared times negative 2x plus now the second term, e to the negative x squared, times the derivative of the first, which is negative 4. Excuse me. I'm going to erase some of this top stuff here so I have room to write the other. Simplifying this second derivative, let's see, we would have a negative 4 in both of them. Let's leave the negative and just factor out the 4. We have an e to the negative x squared in both of them. When we factor that out, we are left with two negatives which make a positive. Oops, I don't usually write a positive x, but I did there. A positive x times x, so a positive x squared, and a negative 1. So we have this right here. There's my second derivative. If that's my second derivative, to find out where my points of inflection are, I set that equal to 0. This part of the function right here is never equal to 0, so I set this part equal to 0, and when you solve it, you get x equals, add 1, divide by 2, square root, so both a positive and a negative, square root of 1/2. You put those back into the original function to find the y value, and you get these 2 points as points of inflection. So we have the square root of 1/2 and 2 times e raised to the negative 1/2, and the negative, that was supposed to say plus or minus right there, of that the same. Those are your 2 points of inflection. Your second derivative tests, let me fill in the signs for you so you can see what it's talking about. It says if your derivative equals 0 and your second derivative is less than 0, it's a local max at that point. If your second derivative is greater than 0, it's a local min at that point. So a little opposite of what it maybe would originally seem. Just think about what your concavity means, concave down, so it would give you a max. Looking at an example of this function is supposed to say x cubed minus 6x plus 5, I believe. You probably have it written on your paper. You take your first derivative, and you get 3x squared minus 6. You take your second derivative, and you get 6x. Alright, so your critical points are when your first derivative equals 0. So 3x squared minus 6, where that equals 0, add 6, divide by 2, take the square root. So it's when x equals plus or minus the square root of 2. You put those numbers into your second derivative. Well, 6 times the square root of 2 is a positive number, so that means at this square root of 2, we have a minimum value. Because your second derivative is positive, it's a minimum. And then we put in a negative square root of 2. Gives me negative 6 times the square root of 2. That's a negative number, and so since it's negative, it means there's a maximum at that point. And then the last two are just slides to look at and to note about everything you can tell about a graph based on its derivative, first derivative, and second. Tomorrow when you come to class, we'll work on our homework and any questions that you have, so feel free to get a start on this. I also want to emphasize that your 5.1 and 5.2 homework should be about finished. Come with questions tomorrow. Have a great night. Bye.